Hey there, mathematicians. So we just went over new types of inequalities where you'll see two inequalities drawn on the same graph. So what we did was we recapped a little bit about how you write inequalities. So we're going to look at number one. Specifically, you look at the pieces that you're given. For instance, I see a closed dot here at -6. So that means that I will use -6. I'm a closed dot, which means that I will have an underline underneath my symbol. And I also notice that I am shading literally to the left, which means my symbol will be pointing to the left. And since I am closed as a point, I will be underlined. So I'm going to put X to show that I'm saying any number less than or equal to -6. Now, the second part of this guy, notice, has an open dot at -5. So that's going to be important here. So we're going to put -5 on the right side here. And we notice that this symbol, or I'm sorry, this shading is actually going towards the right, which means that we are pointing towards the right. Since we are open, there is no underline, and we can put our X. Now, since both of these are facing complete opposite directions, one's going to the left and one shading to the right, we are going to put an or in between because they are literally facing opposite sides. They're opposing each other, like how magnets oppose each other. All right. Now, number two, however, does not look like this. So we're going to, again, take a look at those pieces. So on this left side, I see that I'm an open dot at -8. And which way am I shading? Well, I'm shading to the right of -8. So I'm going to go ahead and use my symbol here. Since I am open, there is no underline, ladies and gentlemen. So I'm just going to put my X. Now on my other side, I have a closed dot over here at -1. That's going to be important. And we are also shading to the left of -1. So that means I'm going to point my symbol going towards the left. And since I am closed as a point at -1, I am going to underline. Now, since this is contained in between, this is not an or statement. This is what we call an and statement. Now, another way we could handle this situation is the lowest I can go is -8. I am also open, so I can be bigger than -8, but I have to be smaller than or equal to -1. So in this case where you have this middle part where you are in between, you can write that either as an and statement, or you guys can just write it all together with X sandwiched in the middle. Now notice the two symbols will be pointing the same way. It's meaning that everything in between is included, or that's where my shading is happening, is in between -8 and -1. So that's kind of neat, isn't it? All right, so we're going to take a look at solving these compound inequalities. We're going to do the or question first. So please write this example down in your notebooks. We are only doing 2 examples for today's class, and then you're going to practice. So first things first, we need to solve for x. So we want to get this x plus 9 by itself, and how we do that is take away 10. When we take away 10 from 13, we get a 3 on the right side. And guys, all I have to do is, instead of dividing by 9 from x, I need to do the opposite. So instead of dividing by 9, I'm going to multiply over by 9. So I end up getting that x is bigger than 27 for this first part. In the second part, I need to get 3x by itself, so we're going to take away 16. And 19 minus 16 is 3. And instead of multiplying x by 3, we're going to divide by 3 from both sides. So we're going to get that x is less than 1. Now, the cool part about this is you can give me this as your answer, or you have this option, guys, that you can type this into Desmos. Now be careful though, you cannot type both of these at the same time. So you're going to type each of these inequalities into one box each. So you'll end up taking up 2 boxes as you type this in, and you'll notice that they are literally polar opposites. And the cool part is that you can see right here that at positive 1, I am shading in blue to the left. I am a dotted line, which means there is no underline underneath that symbol. And we can put an X. Because there's a big gap in between, this is definitely going to be an OR case. We're also going to have our 27, and we are shading and pointing to the right. And notice again, we are a dotted line at 27, which means no underline. So literally using what you see on the graph, or you could literally use solving by hand. Whatever you guys choose to use will be fine. So let's take a look at our last example. This one's a little different, isn't it? And why it's different is because there's not separation. It doesn't say or, and it doesn't say and. Notice that the 7x plus 6 is sandwiched in between negative 50 and negative 8. So what we're going to have to do here is break it apart as such. So you'll do the negative 50 is less than 7x plus 6, but then you pick back up at 7x plus 6, and then you need the less than negative 8. Now, because we split this into 2 and they were sandwiched together, that means that this inequality was an and statement. So now we can actually solve and go through like normal. So I want to get 7x by itself, so I'm going to take away 6 from each. To get x completely by itself, we are going to divide by 7 in front of my x. So we end up getting negative 8 less than x. Now, let's do the other equation. Get the 7x by itself. So instead of adding by 6, we take away by 6 on both sides. We end up getting negative 14 over there on the right when we take away 6 from negative 8. And don't forget to divide by the 7 that's being multiplied by my x. It's side by side. And from here, we should end up with x is less than negative 2. Now remember, this is an and statement. All right, so let's take a look at what the graph looks like. So remember, if you're going to type this into Desmos, we need to use 2 inequalities in 2 separate boxes. Excuse me. And you use the 7x plus 6 not once, but twice, guys. You pick up where you leave off. All right, now listen, when you look at your graph here, you'll notice that you have some overlapping. And that overlapping is how you're going to write your final answer. So you have 2 ways you can write that final answer for based off of this graph. I see from negative 8 that I am shading in blue towards the right side. I am also dotted. Okay. I also see on the other side, dealing with negative 2, that I am shading to the left in the yellow with my dotted line. So I'm going to use that less than symbol. And we can throw the word and in between if we'd like. Now, another way you can write it, guys, is you can use your low bound and your high bound. So I could use negative 8 is my stopping point or the lowest overlap. So literally from here until I reach all the way over here, And my high bound here is -2. And x is literally in between, meaning any of the shading between -8 to -2. Now listen, guys, I'll accept either one of those solutions. So if you give this answer to me like this, I would accept it. And if you see it written like this, or you write it as a sandwich between x, I'll also accept that. But make sure you do your low on the left and your high on the right. Okay? All right, so you guys are going to practice for me using number 4 on Google Classroom. It is a Google slide assignment.